The topic of studies today is chemical equilibrium. We shall find out a relation between free energy change delta G with equilibrium state. And before we get into an idea about a relation between delta G and equilibrium state, or Kp or even Kc, it is advised that our students have basic understanding of the equilibrium constant Kc or Kp, the forward and the backward reaction, and also a reversible reaction. It would be worthwhile to review the related concepts in the present context. Now, we know that there is a relation between equilibrium constant and the Gibbs free energy. How free energy of a system is related to equilibrium constant Kc of a chemical reaction. A simple relation is there, and the relation is that delta G naught is equal to minus RT ln K. ln means exponential logarithm of equilibrium constant. Usually it is Kc. And delta G naught represents the Gibbs free energy under standard conditions of temperature and pressure. Delta G naught, we can definitely remove the exponential logarithm with natural logarithm log to the base 10 by putting minus 2.303 RT log K. So delta G naught will be equal to minus 2.303 RT log K. This K is usually Kc, equilibrium constant. Now, if you look at carefully, we find a negative value over here. That means delta G naught, that is change in free energy under standard conditions, is inversely proportional to K. And therefore, we can easily make out that delta G decreases, the equilibrium constant increases. Inverse relation, delta G घटेगा तो equilibrium constant बढ़ेगा, और इसका उल्टा भी हो सकता है. तो देखिए, again same thing coming back, we have seen that this is equal to minus 2.303 R3 log K. Negative value indicates a spontaneous reaction when K is greater than 1. K का वैल्यू अगर 1 से ज्यादा हो जाता है तो spontaneous reaction होता है, मतलब it is quick reaction. When delta G has a positive value, the non-spontaneous reaction occurs. Now this is very important. This inference we have to make out as represented here. The relationship between delta G naught and K allows us to predict the directionality and extent of the chemical reaction at a given temperature. Delta G naught is negative, and if the value is more, that means the forward reaction more negative. नेगेटिव वैल्यू है लेकिन ज्यादा है, हायर वैल्यू, तो फॉरवर्ड रिएक्शन होगा. और डेल्टा जी पॉजिटिव है, means the reaction will not proceed to the forward reaction, or it will be less directed to the forward reaction and more to the backward reaction. So the equilibrium mixture will contain mostly reactants. When delta G is close to 0 or 0, the reaction is at equilibrium and the concentration of the reactants and products are roughly equal. Well, this is an interpretation about the relation between delta G and the equilibrium constant. One thing has to be kept in mind, that in practice, deviation from the ideal behavior occur under non-standard conditions. So this has to be properly calculated and adjusted. In practice, deviation from the ideal behavior occurs and non-standard. So under these situations, adjustment of the equation is necessary. The temperature dependence of the equilibrium